All right. So let's start with a heads up that, of course, you probably have gotten the notification. So I got a bunch of emails about Pig. Didn't bother replying to any of them. Maybe I replied to one, and I saw because they were all saying the same thing. Please give me an extension. So I just simply changed the due date of Pig to Friday. So hopefully you all got the automatic notification that's due Friday. I'll go over it in more detail after I go over some more administrative stuff. Also due Friday is the first part of the final project, which is the proposal. If that first part of your final project makes you panic, do not panic. Instead, come back to this part of the video later tonight and follow these 3 simple steps. 1, download proposal.md. 2, create an account on GitHub. 3, either edit the .md file on your computer in a text editor, or upload it to your GitHub account and edit it there. That's it. The .md file contains some basic questions such as, what are some ideas you have? You are having? And if you are going to work in a group, who do you plan on working with? That's it. That's really all the proposal is. It's just a brainstorming kind of thing. So if you've got a group you want to work with, try to nail down what you want to do, because on Tuesday, that is going to be a really different class. Tuesday is going to be one of those classes that where basically your required amount of attention is about 3 minutes in class, and then you're done. Because what I'm going to do is I'm going to go group by group, be it on Zoom or in person, and check off your idea, because your proposal is due Tuesday evening, right? The idea you want to have. And again, the proposal is just a file. You fill it out and say what you're going to do. Okay. Your proposal is due Tuesday evening. So the lecture on Tuesday, what that will involve is me meeting with you or your group and asking, hey, what's your idea? And then saying, okay, I think that's a great idea. The vast majority of cases, that's what I say. You tell me like, we're going to implement Hangman. I'm going to say, no, you're not. You're going to do something a bit more difficult than Hangman. Maybe you're going to do the assignment I do in 2168, which is a Hangman that cheats, or a Wordle that cheats so that people can't win it, right? Or, oh my gosh, that is way too ambitious. That's also not that rare. Why don't you just work on trying to get a minimal viable product, a prototype, right? So basically, I'm just going to sanity check your idea. Your proposal can kind of be changed a bit afterwards, but it's got to be kind of the general same line, because you don't want to start all the way over from scratch. Okay. Now for the final project, I sent out an announcement on Tuesday. And again, sorry I couldn't make it that day. Sorry that we have to meet via Zoom today. I am sick. If you can't tell, I sound pretty bad with this. I've been basically conserving my voice for my classes. So the email on Tuesday should have contained 2 videos. The first video had a link at a specific time index, which was for Git. So it would basically, it's for the last quarter of that video. I talk about Git and how to use it, which is what you'll be using to turn in your final project. It also helps basically track your changes and help coordinate between group members. The second video is all different ideas and different kind of things to do for the final project. I'll reiterate it in case you didn't check that out, though. I will reiterate it here. If you are lost for an idea of the final project, check out Module 11. Module 11 has 3 tracks that you can try: the gaming track, the web track, and the mobile track. Each of those tracks has about 2 weeks worth of work for you of lectures for you to look at, which tells you step by step how to build an app. The first one, like gaming, will do Pong and then Mario, and then there's different apps for other stuff. So like the first one is a Pokédex. There's also like a Instagram kind of filter. An Instagram kind of mobile project would be great. Taking following the steps for that final project and then adding a bit to on it. So basically these final projects, the tracks serve as great core foundations for your final project, but I want you to add something on top of that if that's going to be your final project. So for like Pong, it should be Pong with extra steps, Pong with a few extra things. For instance, my version of Pong was a version of Pong where the enemy paddle would slowly get bigger and bigger and bigger until you got 7 points, and it would get obviously much larger because it covered 1/3 of the screen. And when it started, and once you hit 8 points, it would start, you would hit it at normal speed and it hit it back at 10 times the speed. Yeah. So doing stuff like implementing power-ups, that's perfectly acceptable. Any kind of old game with a twist, always good. Snake with a twist, Donkey Kong with a twist, Mario with a twist, just a twist. Don't make just another clone. Okay. So, mobile, and so the web development, making a web page, also a viable thing. So the next, so my other suggestions are as follows for people who are having trouble with ideas. The building something track, which basically means get a Raspberry Pi or an Arduino and do a project with that. Basically get a small computer or chip and learn how to use that. And again, the video demonstrates how to use like a laser tripwire with that. That's a great idea for a final project. And in the video, it says, here's the extra steps you can do, like sending a text message to you or sending out a tweet. Discord bots are very popular final projects, perfectly valid. I mentioned this in the video as well. Making a choose your own adventure book or visual novel via Ren'Py, which allows you to still work in Python. Pygame allows you to still work in Python. And then as everybody is becoming like super into AI art and stuff, using that is allowable. However, you're not going to be using the front. You shouldn't. If you're going to do that as your final project, you're not going to be using your front end. You're going to be making sure you're using a Google Colab notebook or something like that to actually, you're actually going to be using the coding framework there, and not but if you want to do something AI art generated, AI art based or something like that, that's a great place to start. Okay. Again, what I care about in this is that, did you participate and did you learn? Okay. So, now incentive. So as I said, I don't really have I'm about to take that. So there is a couple of things. So what we have left in this course is the final project, exam 3, and final exam. Now, as I've said, my standard for getting an A, basically, if you work hard and you do this, you're going to get an A on the final project. Okay. And you've got something that, that meets my criteria. Did you improve the world in a small way? Doesn't matter how small. Did you amuse me for a minute? Right. Those are kind of my criteria for an A. Probably, Michael. So what's the incentive for doing more than the minimum? Well, the best groups get exempted from the final exam. Okay. The best project or the best group is exempt from the final exam. So, basically last day of, class 1 Monday, and I'll start going through the final projects and we'll be looking for basically the ones that stand out the best. So I sent out the videos in an announcement. What day is our final? I don't know. I will figure that out. I find it out the same way you do, which is that I find it out via, by looking at the exam calendar, and I don't bother worrying about it until much closer. What we do need to worry about is exam 3, which is coming up. So, because let's consider this. We have this week, what remains of this week. Then we've got the week of the 7th, the week of the 14th, and then days 21 through 25 is Thanksgiving, right? Is the fall break. And then we've got the week of the 28th, and then we've got the hanging Monday. So basically what it comes down to is, do I give you exam 3 before Thanksgiving or after Thanksgiving? And I personally think that I should give it to you before Thanksgiving. And exam 3 will go over, I think. Now, so that means that exam 3 will be 2 weeks from now in the 17th. Now, what is this going to go over? Well, again, like I said, I'm going to be grading this this exam over the weekend with your TAs. If you did so, if this exam was super brutal on the end, then, and you know, a lot of people didn't get to the last questions. Well, I suppose then asking questions similar to the last questions that you didn't get to would be a good place to do that. Would be some good questions. Basically, I'll probably cover the same things as we did in exam 2, with the addition of doing Monte Carlo approximation, which is what Pig goes over. So I'll give you a game to simulate. So if you do well on, I don't change the raw scores. The curve always applies to the way the curve in my class works is that I change the range for A's. So like 88.5 was the range for an A minus. So I don't curve the raw points because it makes the calculation hard. Yes. And again, there's a couple, I'm not going to make any commitments as to what I'm doing for the second exam because I have no idea. I have no idea what all the emojis mean at this point. I think at this point, people are just messing with me. So, but regardless, exam 3, we're going to go over for the, I'm planning on doing Monte Carlo approximations. And if I get the chance, regular expressions. Otherwise, regular expressions will appear on the final. Or maybe I don't even get to them. No, I will always do regular expressions. The question is whether or not it's going to be on the final. I really like regular expressions. Really, really, really like it. So exam 3, expect basically what we did for exam 2, especially if there's a question that a lot of people missed. I'll know better when we grade exam 2 this weekend. And a question about Monte Carlo approximations. So my plan today is to go over Pig because I know a lot of you are stuck. Yes, the final will be cumulative. Let me explain to you how the final exam looked last semester. The final exam looked, yes, there will definitely be another practice exam. The final exam last semester consisted of 3 questions, I believe. Question number 1 was my regular expression file reading question, which is given a file. Please remove all, and it was something along the lines of this. Given a file, please remove all social security numbers from this file. Something like that. Yes, dictionaries and yes, Mara, thank you. Dictionaries and yeah, well, the dictionaries will probably be part of the will also be part of that exam 3. So the final exam consisted of that problem, which is given a file, replace all the social security numbers in that file with the word censored, write out that file. That may sound tough, but if you know regular expressions, I showed you how to do problems pretty much that were identical to it, and it took about 10 lines of code. And that includes the open file commands and the close file commands. The second problem I had was, here's a file. It does some, here's a turtle file. It's a working program. It does stuff. The names are terrible. Like, it's got stuff like earwoo as a variable name, and spinny and zoink and and names that don't mean any sense. Tell me what these variables do and what changing them does. In other words, do you understand how code works? Do you understand how to experiment with code? And do you understand enough to see how to see those things? The third problem was a Monte Carlo approximation. I think last semester I did Dungeons and Dragons, which was which is here's some basic rules. What is the chances that a first level fighter one hit KOs a goblin in fifth edition? Which was basically roll a 20-sided die, shoot randomly generated number 1 through 20, add a number. If it's above a target number, then roll for damage. If that's above a target number, you win. Simulate this 100,000 times. That's how you do a Monte Carlo approximation. So that's how I did it. It was 3 questions for the final exam, and I see no reason to change it for that. I like having 3 very broad questions that basically nail the topics. But for exam 3, for exam 3, I plan on doing again Monte Carlo approximations. So let's go ahead and get started with that Monte Carlo approximations. Any questions about the final project before I move on, though? Again, watch the videos about the final project. Tuesday, I will be be prepared with your group to basically, if not present your idea to me, then just tell me what it is, what you plan on doing. All right. Let me open up VS Code and here is pig.py that we had. Right, this is the code we had last time, I believe. Right, this is the code I downloaded from our file. So we have this auto pig here, and we have this hold at 20, which if I run it, file preferences setting, terminal, font, terminal font size 26. There we go. And font size. Wait, that makes sense. That's fine. All right. So this was the first part of the first 2 parts of Pig, which was here, play a game of Pig where simulate a turn that a computer would typically do, which is that if I'm going to roll the die, right? And I'm going to keep rolling it until I hit 20 or bust, right? And part 2 basically says, what are the outcomes of that? And we see from this that we go bust 62% of the time with that strategy. Okay. That's what this tells us. Around 62% of the time we go bust. And we don't calculate this by doing any messy statistics. We do this by playing the game 10,000 times. Okay. But here's the thing. This is what so what part 3 is saying is, okay, we've got this strategy called hold at 20. And by the way, I should clarify because I've got this a few times. Bust is a term from blackjack, where if you go above the target, a score of 21. So in other words, you basically made a mistake and now your score, which was high, is now 0. Or sorry, your turn total, which was now high, is 0. That's what going bust means. It blew up. So here we rolled So here, part 1 says we've got this strategy, roll until 20. That's also a strategy that only the computer needs to adhere to. You should let, when you program humans playing for part 7 and 8, you should let humans make their own choices, like being able to get more than 20 points a turn if they want to risk it. All right. So what I'm going to do here for part 3 is that it says in part 3, and let me go to modules. Give me 1 second to pull it up on my end. And yes, I know you can't see it. Part 3, it says, hey, I want the user to specify the hold value. What is the probability of reaching a single turn? Sorry, 100 in a single turn. So here, rather than holding at 20, rather than stopping when we get above when we get to 20 or above, we want the user to be able to say whatever. So what I'm going to do here is I'm going to modify my part 1 a bit. I'm going to modify this to be, and I'm going to create something that the book may have not talked about called a default variable. So notice that so here, what I'm going to do is I'm going to run this. And notice that it still runs, nothing's changed. What I've done here is I've created what's called a variable with a default value. I've created a variable called hold value, and I said its default value is 20, which is what it was here first. And while the amount we roll that turn is less than the hold value, which is 20, and we didn't bust. We didn't roll 1. We keep rolling. Okay. So even though this now takes in an argument, notice it's still running without crashing. I didn't pass in an argument. But here's the fun thing. Now, if I put in an argument over here, say autopig 10, I give it a value. And now it's went from being 20 to 25 to being 10 to 15. So now, the way default value works is that if you don't pass in anything, I'll just use this value by default. If you do pass in something, I'll use that value instead. Does that make sense to everybody? Now, the alternative to doing this is that we could just make a second function. But I mean, I'm late. This is the easiest way to be lazy. And I like being lazy. So part 2 and 3 done. Okay. So here they want to know what our chances of getting all the way to 100 is. So here now I've changed the strategy to being, instead of hold at 20, to be hold at whatever value I pass in. So hold at 10, we tried. Hold at 30. So here we have a 76% chance of not scoring anything because we'll roll 1. And if I say hold at 100, where I try to go from 0 points to 100 points, does the compiler run the default value first when you pass an argument or not? So there is no compiler for this. It just simply notes that there is something called a function called autopig. Sorry, the interpreter will note that when it's reading through that there's a function called autopig, and it takes in these arguments. It takes in a default argument, and then it moves on because it's not executing any of the code yet. How do I run everything? By not clicking the button on the top right. The ancient secret of keyboard commands. I am hitting Control F5 to run. Which is right over here, as you can see. Run without, if you see over here, they always list these keyboard commands over here for things. And so I'm doing the run without debugging. Same thing works for idle. Hitting F5 on idle will run it. Just be warned that on your laptop, that it may be set up so that your things don't set that the function keys are instead like volume keys or something like that. Get a key error for hold at 20. I don't know why. I'm going to change this to hold at X though. Hold at X to make it more in line with what they want. Hold value, and we'll replace this over here. And now I'll just pass in this over here. So if you get a key error, that probably means you're not doing something right over here. Make sure you're doing plus equals and equals over here. And that you're doing this over here. Make sure it's turn total in outcomes, not turn total in sorted outcomes. All right, so let's take a look at part 4. Part 4 says hold at 20 or goal turn. So the idea behind this one is says, given a player score, and I know you can't see it, just listen to what I'm saying. Given a player score, simulate a single turn of pig where the player rolls until they hit a 1, or the turn total is greater than or equal to 20. Or the score plus the turn total is greater than or equal to 100. So over here, we had 3 conditions for auto pig, which is that we wanted to, while we hadn't hit a 1, and while our value was, our total value was less than the target number of points we were aiming to get, right? Which is 20 by default. So while we've scored less than 20 points and while the player hasn't rolled a 1. So what this one is hold at, which is what this one is asking for, the hold at 20 or goal turn, is asking one more thing, which is while we haven't won. So I'm going to copy this. Part 4. And this, believe it or not, requires one quick change. So, and we're going to give it a different name, hold at, so I'm going to call it hold at target or goal, because I want to be able to vary my strategy possibly. See how it works out. Hold at 20 or goal, hold value. So here, what we're going to do is we're going to pass in a second argument. Well, what we'll do actually here, you know what, to keep it simple, I'll just simply keep it at hold at 20 or goal, because I don't want to have to get into position. And why not? You always need your so here's the rule with mixing default values and these values. The order in which is right, Python, the way functions work is that it's always order based, not name based. So in order to mix, regular variables with variables that have regular arguments with arguments that have default values, you need to put the ones that are mandatory, that have to be passed in first. Score has to be passed in first. So here, what we're asking is for not just the score, but the current score, whatever the user has. So while the total is less than the hold value, and we haven't rolled a 1, and the total we have, the total amount of points we've scored, plus the current score. So what we've got in this turn, plus what I've scored already, is less than 100. So the reason for this is, say I'm at 90 points, okay? Say I'm at 90, I'm at 90 points and I want to try to win. Okay, the hold value is by default 20. Yes, you're allowed to use my code. That's why I'm doing this. Okay, the hold value here is 20. Okay. So if we didn't have this clause, I wouldn't win unless I had managed to score 110 points. or 111 points technically. No, 110, because I'm currently at 90, because I'd have to score at least 20 points. So here, this clause allows us to win to stop rolling after we got 10 points, because, right, let's say I'm at 90, I roll a 6, I roll a 4, I'm at 100 points. Without this clause, I would say I would risk rolling a 1 and losing it all, because I hadn't scored 20 points this turn yet. So by incorporating the score and saying, hey, the amount I've got in plus the score, 10 plus 90, that's greater than 100. So my turn stops. Now, what it's saying over here to return is, well, honestly, you can either return the new score or you can return the total that you got for the turn, which is what I'm going to do here. Either way works, because it's asking you to print out the progress there, which I'm not going to do because that's your job and stuff. I'm just kind of showing you how to get out the answer there. Okay. So now with problem, so the rest of the stuff, again, I'm going to leave to you, but let me go ahead and talk about how to do them. Okay. New share. So let me talk about how to do this problem. So this problem 5. Part 5 should use part 4, because what you're doing is that you are trying to basically see where you're winning, basically playing a game and simulating the output of a single game. Here, this player has 86, and notice that when he gets 19 points, that's enough. He needs to stop rolling. So he does stop rolling and wins the game with 105 points. So it's using the roll method in part 4, much like part 3 used part 1. Part 6 will use part 5. What you need to do there is that you modify part 5 to keep track of the number of turns. You can find this recording on YouTube. I will upload it after the lecture. Part 7 is going to be a bit different, because here what you're going to be doing is you're going to be following the logic of because here you're making basically it's completely human controlled. Now remember, humans can be dumb and they don't have to follow any particular decision or not. They have to let's see. So humans can follow decisions like, oh, I only got 6 points, I can hold right now. Oh, I got 20 points, I want to get more. That's a decision a human's allowed to make. Make sense? So now part 8, which is basically a player playing against a computer, which is the full thing which is our full game, that's going to combine the strategy of part 5, because so the computer is going to use part 5 and the human's going to use part 7. Make sense? So you're basically combining those two programs together. Okay. So I've given you half the problems for this one. Any questions on this before we move on and I do some more more generalized Monte Carlo stuff?
I have a question.
Sure.
I think it was part 6, or I'm sorry. Yeah, part 6. When I put in that value of games, I got like 11.58. Is that okay, or should it be closer?
I would run it a few times and see how swingy it is. It can be, if you're getting like anywhere between 11 and 13, yeah, that's probably good. If you're getting like in the 30s, that's probably wrong.
Okay, perfect. So I think I got like 11 point, an average of 11.6,
Mhm.
I think.
Typically what happens for this, by the way, is that it's not wrong so much as the student decides to count the wrong thing. Like a and what do I mean by that? Wrong thing like they count the number of rolls rather than the number of turns. And yes, you can use all of my code. That's why I gave my code.
Okay, thank you.
That's why I gave my code here so you could use it. I'll post it on Discord in just a second. I'm just double checking the problem that I wanted to go over, which is basically the problem I have on one of the problems in the video, which was yep, okay. Yep, David, what happened there is probably you were counting the number of rolls. So you probably just need to move your counter out of the loop. All right, so we're going to go ahead and show you what kind of, so now that I've talked about, so this is a homework that's very relevant to doing, so PIG is a homework that is very relevant to exam 3. So why don't we go ahead and focus on the kind of problem that I would love to give during exam 3, which is I like to focus on games of chance or games that involve chance. Okay. So let's go over. So I'm going to go ahead and share my screen for a bit again. No, actually, let's go ahead and I've got my Wacom tablet over here, whiteboard. Thank you, Microsoft. Okay, and you know what? New whiteboard. Share screen. Because Microsoft Whiteboard generally does a better job of this kind of stuff. All right, so here's my game of chance. Okay, and suppose we're playing. I'm playing a game. Okay. Oh, sorry, that I propose a game to you. In this game, I say, here I've got 1, 2, 3, 4, 5 cards that are black cards and 2 red cards. So like if you look at my video, you know, like playing cards, right? Here the suits are, if you look at my video, right, some of the suits are black, some of the suits are red, right? Makes sense? Some of the card, like here, the Queen of Hearts, it's a red card. King of Spades, black card. So suppose I pull out 7 cards. 5 are black and 2 are red. And I say, let's play a game. If you, I'm going to flip these over so you can't tell which cards are which. So I'm going to flip them over and you'll have these 7 cards here, which you can't tell which are which. And I'll use the rainbow colors to specify that you can't use, tell which are which. Right? So you've got 7. So we've now got 7 unknown cards. Now your objective is to flip over 3 cards. Right? Flip over 3 cards without flipping over a red card. Okay. So maybe you'll flip over this card. Doesn't matter which one. Flip over this card. Flip over this card. And if you get all 3 of them, right? If you don't flip over if you don't flip over a red card, you win. And I'll give you $1. But if you flip over a red card, no matter where it is in the sequence, so say your first thing you flip over is a red card, or you flip over, 1 card, and then you flip over a second card, and it turns out it's a red card, I win, and I get $1. The question is this a fair game? Now, the answer, of course, is no, because I'm asking you if this is a fair game. That's a loaded question. Of course, this is not a fair game. But why is this not a fair game? So we can use some mathematics and stats to prove that this is not a fair game, because it seems fair, right? Like when because your chances, let's think about this. If I just had to do this once, there's five cards that are black out of 7, right? Total cards. That's a greater than 50% chance of winning. Then we've got 4 cards left. And there's 6 cards that we have to pick. 4 of the 6 cards that are left, greater than 50% chance of you getting it right. And then if you've flipped over 2 black cards, great. Then 3 of the remaining 5 unflipped cards, more than half of them are, more than half of those cards are black. So you've got a more than 50% chance of flipping over black there. So your odds of winning the entire game have to be like 50% chance or more, since all those chances are 50% more, right? That is the typical line of logic they would use to learn you in. But here's the way, and it's fine if you don't know this, because you wouldn't know this unless you take statistics. But when you're dealing with these things with probabilities that are related to each other, you multiply them out to figure out what your totals are, your total odds are. So your total odds would be this, which is 5 times 4, which is 20, times 3, which is about 60, right? That about right for the top? I'm doing them. Okay. Then the bottom would be 30 times. So this is 30, right? Times 7. 30 times 7 would be 210, right? Cancel out the zeros. Divide by 3. So your total odds are actually around 2/7. Your total odds of winning are 2/7, because in order to get to this point, and the reason is, in order to get to here, in order to get to this point over here, you first had to pass this point, and in order to pass this to get to there, you had to pass this point. They aren't unrelated. They're related, therefore they get multiplied. But you haven't taken statistics yet. So what are you supposed to do? The answer is we simulate this problem with the Monte Carlo approximation. We know how to shuffle. We know how to slice. That's all we need to do in order to figure out this problem. Right? This is kind of the difficulty of the question I would want to ask on an exam. Okay? Which is some kind of game of chance. Maybe a bit easier than something I want to ask on an exam, but basically something where we've got a game of chance, and I'm trying to say, hey, write a program that calculates the real odds, because the scammer is going to say 50% chance or better, which to me, it sounds like an even or odd chance of making money, or just coming out with net zero. True fact here, by the way, if you think that it's kind of weird that I'm talking about game of chances, because like things I might do is why am I talking about like game of chances or like gambling games or those kind of things when I'm talking about doing like statistical stuff? Okay. The reason is because the reason we have statistics and probability as a field is because of gambling. It's how that's how some of our somehow the big mathematicians back in the day got paid on the side by calculating the odds, because nobody actually had bothered doing that yet, at least in their geographical area. That's another thing with math. Things get discovered and rediscovered all sorts of times. Okay. So let's go ahead and actually code this up. Okay. But again, to remind you, we have 5 black cards, 2 red cards. And we need to pull 3 without pulling a red card. So what is that going to look like? red black.py. Okay. So here, what we'll do is we'll make, and the general way I like to do these Monte Carlo approximations is that I have depending, either I like to simulate a game or a turn of a game. It doesn't really matter, but basically I have a function that simulates one of the things that I'm trying to do. And then I have a loop out on the outside that runs it. Okay, so here is our game. The game consists of, here's our cards, and I'll put them in a list. Oh, before I do that, I need to import random because I always will be using random for this kind of stuff. So cards is equal to red. So let's go ahead and just simply, we've got 2 red cards and black. We need 5 black cards. I could basically, do something I could do some like fun multiplication to do that, but honestly, it's not worth the time. So here's our cards. Now, in order to set up a game, right, we've got our cards. Obviously, the R, by the way, is a red card and the B is a black card, right? They're just strings, but we can use that. So in order to set this up, we want to do random dot shuffle. It's one of my favorite things to do with these kind of card problems. And it says, and it shuffles it in place, it says, doesn't return anything. Boom. And here's our test statement to kind of show what's going on. I always delete these things afterwards, but like here's where I show where I'm going to do. Oh, it doesn't print anything out because of course I do that thing which I always do, which I write code and I forget to call it. So here we can see that the cards are getting shuffled, right? The 2 reds are appearing in separate places. Okay. Now in order to do so, there are a couple different things I could do here. I could make use of the random function, and there's a random dot choices, which returns a k-sized list of population elements chosen with replacement. So that's not what we want because it would draw 3 cards, but it puts them back after it draws them. Same with choice. So there's 2 ways we could do this. The first is that we can use statistical tricks, which I know that where I say one card is the same as any other card. So I'm just going to always pick the first 3 cards. Right? Or what I can do, or I could do something like this, where I, actually would remove cards. But and that would involve using del to delete stuff or cards dot remove to remove the first occurrence of a value, which wouldn't necessarily do what you want. But here, this should work. What I'm going to do here is saying, I'm going to do the same strategy. I'm going to flip over the first 3 cards all the time, because honestly, there's no difference between me flipping over the first 3 cards versus any other cards. So my selection of cards is equal to cards 0 up to, but not including 3 for the first selection of length 3. And let me just check one more thing. If there was a random dot choices, random dot, I'm pretty sure there is something in here that I could use. I feel like there's a random dot sample. There we go. Random dot sample 3 k unique elements from the set. So it returns a new list containing the elements. So this allows us to raffle winners. So So sample counts 4-2. So that should work, I would think. What's rand stir do? Is that a random string? I don't think that there is one. Or I'm not seeing it here, but it would be getting something from there. But honestly, it's worthwhile to look at the random documentation. I think that would right here. I'm going to use selection, and then I'll experiment with the sample. So selection, and now all we have to ask is that if red not in our selection. So if we did not choose it, return true, else return false. Trials is equal to 100,000. We'll play 100,000 games. Wins is equal to 0. For in range trials, if game, so if that returns true, I don't need to bother putting the equal in there. So if range win, so if I won the game, add a win. Else do nothing. Print wins divided by trials, or the percentage. And then if I want to make it pretty, I can do something like this. Oh, nah, no worries. Run it, and it says, hey, 28% chance. Hi, yes.
I just have a question about like, what exactly is the Monte Carlo part? Is that just like that end when you, or is it like the entire thing of using random and
It's the
dividing by
entire it's the entire process where we are simulating these. I mean, I guess I would say it's the entire thing. The whole let's make a turn and then simulate it, or a game and simulate it and see what the outcome is.
Okay, thank you.
That's what when I refer to Monte Carlo, basically we've got some statistical question, but but statistics and math is hard. So instead we just play the game.
Thank you.
So for in range trials, if the game wins plus equals 1. So here we had a 28% chance of winning. Let me go ahead and see what the random dot sample would have been. Cards 3. Okay, yeah, that would have done exactly what I wanted it to, which is that it would have just done 3 without, it would have selected a subset of 3. In other words, it would have chosen 3 cards and flipped them over at random. So the difference is that choices would have selected them so there's 3 ways to choose things in statistics. Sorry, there's 2 ways to choose things with statistics. You choose it with replacement, or you choose it without replacement. In other words, whether or not you flip it over and you flip it back, if you flip it over and then you flip it back over, essentially, or you flip it over and you remove it from the consideration. Yep. 2/7 is about 28% of the chance. So the idea here. Oh, sorry. Oh, sorry. The 2/7 I lost my train of thought because I just got so clogged up. Sorry about that. 2/7 is about 28% chance. So the entire point of this is that things that are hard we can simulate with this. Yeah, the games are rigged. In fact, a lot of the games at casinos are rigged in favor of the house. There is one game where the player can have a slight advantage. Anybody know what game that is? When played perfectly, blackjack can favor the player. Especially if you know how to count cards, which is actually not that as hard as it seems, although it is also not easy. So let's see. You want to put your money in the stock market. The easiest way, the best option for that is index funds, always. Because stock market is a long-term investment, not a way to get rich quick. If it was a way to get rich quick, you'd see a lot more people getting rich quick. Occasionally you'll see somebody who goes YOLO on something and win big, but more often you see people who are just left losing all their money if they try to basically put all their money on a stack, on the stock. Long-term index funds. Okay. Now, with regards to, so this kind of game is a lot of fun. So, let's try a different so I'll leave you with a different variation, which if you're interested, you can look at the videos listed in the, if you're interested, you can look at the video that I have listed in the, that I linked on GitHub. So you can look at the video that I put in the announcement, the first video, the one that directs you to look with the instructions on how to use GitHub. We'll go over this problem, but I wanted to leave it as kind of a thought for you because I am apparently running out of energy. Sorry. And, you know, being sick is still rough. Okay, so let's go ahead and use, so this is a variation on this problem. And I believe these problems came from a book called How to Cheat at Everything. You'll find that the best people for fighting scams and going against scam artists, by the way, are people who were former con men themselves or magicians, but I repeat myself. So, now magicians are great, but like there's people like James Randi who basically dedicated themselves to basically debunking these kind of things. You know, these basically people who would use, you know, magic techniques. But these are the kind of things that are, you know, good to know. So here's our game. 7 cards. So now, rather than having 7 cards, we'll have 9 cards. But this time, rather than laying them out willy-nilly, we're going to go ahead and lay them out in a 3x3 grid. Okay. Seven of the cards are black. Let's see. 2 of the cards are red. Okay. We don't know, but you don't know because they're face down. Your goal is to basically tic-tac-toe this. Flip 3 in a row so that you get only black cards, right? So if you flip these 3, and so this may seem like you've got better chances because you've got 9 cards as opposed to 7 and you're still flipping 3, but you're constrained to your choices now because you got to flip 3 in a row. So if you flip these 3 in a row, you'll reveal 3 blacks and you'll win. But if you flip this way, you'll lose. And so that actually comes out to, let's count the number of ways that this particular setup wins. That's a loss. So 1, 2, 3. 3 ways of winning. And how many ways are there are losing? 1, 2, 3, 4 ways of losing in this particular setup. 5 ways of losing. What did I miss? 1, 2.
The bottom row.
All right, 5 ways of losing. There we go. Awesome. I was just testing you. Y'all did a great job. So that's kind of terrible odds there for just that. But maybe this example was a fluke. Maybe this example was a fluke. Well, no. But again, the way we do this is now the way we do this is to now I don't know how to do the statistics for this. This one is a bit harder for me to figure out. But honestly, again, like as David pointed out, joke's on you, I'm bad at math. I don't care anymore. This is why I took numerical analysis, because getting the actual answer is hard, but if I get a close enough estimate, that's good enough, right? So here, what I'll do is that I will lay out these things in a 3x3 grid, right? Okay, or I could just lay them out in a line again and do the same thing, which is choose the first 3 cards. And I'll choose this card, and this card, and see if I win. Same kind of principle. But flipping over 3 in a row, it's the idea here is that there are more ways to lose than there are to win. And I mean, even if it's 9 cards, I mean, again, it's not particularly good odds for you. So these kind of games of chance, I really like them. On practice exam 2, the one I sent out a while ago. Let me go ahead and so I sent this one out. Okay. So the practice exam that I sent out a while ago. Doop, doop. Yeah, don't get too excited about those. That was the group exam for another class. Okay. This is an excellent, it'll say these are part of exam 3 in good practice. So here is something called Penny's game, which you can look at. And I've got a YouTube video linked down here done by the Numberphile, which explains this game and explains that basically it's another game that looks like it's fair, but it's rigged. And then here's an example question that from an exam 3. The reason it's listed on exam 2 is I used to do 2 exams. So this is a question that I have given in the past. Okay. Which is simulating Monopoly. I'll also go over probably on next Thursday, one of the questions I've given, a Monte Carlo question I've given on the final exam previously. Okay. So again, so before I dismiss you, here's what's going on. Weekend, I'm going to be grading with the TAs. Assuming they reply back to me and tell me they can do it. I'll be grading anyway, but hopefully they'll help me. So Tuesday, I'll be going over your proposal. If you have a group, please meet with me in your group to, talk to me. And on Tuesday, I will meet with you either in person or over Zoom during the class session to talk, so you can tell me what your project is. If I think it's good, great, I'll give you the thumbs up. Otherwise, I'll tell you, you need to try, what you need to do to make it a viable project. And then once I meet with you, you are done for the day. You can leave. Okay. So then it's not the most efficient use of class time in one respect, but it's also like the easiest way to coordinate doing this, to making sure that every one of you gets the attention you deserve on that. If for some reason you can't meet me during that class time, or I can't get to you, I will meet with you that night. It doesn't matter how late it gets. Okay. But basically, again, your proposal, all you have to have done, you don't have to have any code done. You just have to have a file uploaded onto your GitHub account or your group's GitHub account. Only one of you needs to have that as a GitHub account. You know, if you're working a group together, only one of you has to have a GitHub, I think. If you're having trouble figuring out a final project, again, refer to module 11 or, talk to me. I don't have the energy, unfortunately, to meet with students via office hours today. Hopefully I can meet with people tomorrow. Okay. All right. And then again, your third exam will be right before Thanksgiving, which will be on the 17th, because I don't want to give you an exam after the break. That seems like just a really jerk move. And again, your incentive for doing well on the final project is the best projects get to be exempt from the final exam. Okay. All right, everybody, take care.
Thank you. Feel better.
Good night.
Bye-bye.
Thank you.
Thank you.
Thank you.
Yes,
Thank
even
you.
if you're not in a group, doesn't matter what the project is. The best projects, doesn't matter how many people work from them, get exempted from the final exam. And I don't have a hard limit on the number of best projects there are. If I can't, typically I try to choose like the best project from a section. But if I can't decide between two projects, I'm just gonna give that. Yep, chapter 11 and chapter 12. I think they're whatever I've given you as assignments for reading. We are pretty much done with Runestone at this point.
All right, Professor, get well.
Thank you.
Speedy recovery for you and your family.
Yep. Well, my kids all recovered for the most part, except for
Oh,
his
that's
cough.
good. That's good. Now you got to tough it out.
Oh yeah. Yeah. All right.
Have a good one.
Any last minute questions?
Yes. Hi. Hello, Professor.
Yeah.
I know that I'm not going to be in class on Tuesday because I'm poll working and I'm going to be off campus.
Oh, that's right. It's election day. Shoot. Okay. Yeah.
For
Yeah.
all day.
Just
Should I?
either meet with me. We can meet Monday or I can give you an extension to have it done Wednesday.
I would really appreciate an extension for.
Please
Wednesday.
shoot me an email so that we have a record of that, saying we discussed it and I okayed it.
Certainly, yes, I will. Thank you.
Okay. And thank you
No
for doing
better.
poll working.
Hi, Professor. I have a quick question, please.
Mhm.
I will be out country on the 17th. Can I talk to you on Tuesday about it?
Yes, we can arrange for you to do that. We can arrange for you to take your exam
Okay.
at a different day or time, or even remotely, over the break.
Thank you so much.
So Mariam, I plan on teaching. So for the most part, when we get to the final exam, we're going to be relying on basically things we've learned through October. We aren't really going to be learning anything. All the new learning will be independent on your part for the most part. That said, I do plan on going over at least one thing, which is regular expressions. I plan on basically hammering and reviewing and strengthening the skills that you have, but there shouldn't be any need, but it's a matter, but basically if you could perfectly retain everything that you learned from now to then, you should be good for the most part on the final, except for regular expressions, which is going to be the only thing new. And regular expressions is basically the only new thing. Again, you've noticed that we're doing Monte Carlo, but Monte Carlo isn't necessarily, we started that a couple weeks ago. That was a week or two ago. But I wanted to go in more depth about it. Make sense? So I'm going to be going in more depth about stuff. So like but like the tools I present won't necessarily be needed other than they're helping hone what you already have. Regular expressions is the exception to that because it makes a lot of things a lot easier. Like the problem like I said, I plan on asking a question about Social Security, removing all Social Security numbers from a file or something similar, like removing all emails from a file. You can do that without regular expressions. You can do that with a bunch of if-else statements, but it takes a bunch of if-else statements, a lot of them. If you use a regular expression, you can do it in one line. That's kind of the difference. So I'm trying to basically teach things that will make everything easier. Also, regular expressions don't really fit into the curriculum anywhere, but like, as this is what the professor wants to go over. So I'm going to be talking about things like recursion, which we're not going to use in class. I'm going to be talking about things like big O notation, probably, or sorting, which I'm not going to really test on. Yeah. All right. Take care.